I made a mistake on the processing unit. So we have memory, which is input gets fed into it. It's controlled by the control unit. In the middle here we have processing unit, which is fed by memory and back to memory. Inside we had the ALU, and then I had in here, I said temp. These are also known as registers. I said they were here. They're up here. So these registers are up here. These are the ones where we have the temporary storage. And I said they were in here, but on here was only the instruction register and the program counter was there. And then of course we had output over there. So, like I said, clarify this one. This is where our registers are, not in the control unit. I said on Friday. That way, like I said, I had to draw an arrow down here. That's what made me confused for a second. So we don't have an arrow going down to the control unit. The registers right there.
What is that in next to PC?
Oh, this is the I. Sorry, I'm writing too fast. So this is the instruction register. So, all right. And then, of course, we have the
Is that the one that does the math?
what? No. PC. No, the IR just holds. It is the instruction register. It holds the. Yeah, the ALU do their math. And so, let me go over. I'm going to go over the, some examples. Let me first talk about. We have what's called an instruction. Since we're using the LC3, we have 16-bit instructions. And so first 15 through bit 12 are known as the upcode. Or in probably better terms, you want to say this is actually the instruction or operation. So this is where basically 15 through 12, these 4 bits tell us and not any operation that the instructions set, which we'll talk about in chapter 6, I believe. And then so the last bits, so bit 11 to 0, are known as the operands. And anything you want to say is who to do the instruction to, or the operation to. This varies on instruction of what is inside here. So that's what the instruction looks like. So the IR, inside the IR, what's that?
Ryan, what's that say up there, 1, 2, 1, 1?
Yeah, so this is, we got, this is bit 15 through 12.
Oh, I see.
Is the upcode, and then
I
bit
thought there was
11
one
through
number.
0 are known as my operands.
Okay.
Okay, so this is just for the LC3. Like I said, Intel architecture, dev, same kind of instructions, but these are different. according to their architecture. So then one more thing. I mentioned probably too quickly yesterday on Friday. We have the instruction cycle. So the first was known as fetch. So our PC is currently pointing to somewhere in memory. So we had a block of memory here that had, I had earlier with add. So this is my instruction add. So this is where I want to equal to. So I want R0 equals R1 plus R2. That's what the instruction means. So the PC is currently pointing to this memory location. So I'm going to say a hex 3000. So in here, this is pointing to hex 3000. So the computer at the fetch, the first thing that it fetches is takes this address, takes this instruction, moves it into the instruction register. And then increments the PC counter. So now, this is incremented by 1. So now it's pointing to this next instruction. Right? And we don't care what it is right now. So it's just pointing to that one. So
That's 3001.
yeah. So PC is now pointing to here after the fetch is executed. So fetch went out, grabbed that memory location, put it into instruction register, then incremented the PC counter. So that's all the phases that happen in the fetch stage. The next is decode, which hopefully is explanatory. So the control unit is going to decode that. It's going to figure out what am I going to do. So it figures out, oh, I'm going to do the add operation. And so it knows now it's going to do the add operation. It goes to the next state, which is evaluate addresses. Since I'm using this add instructions, I don't have an address to calculate due to the fact that all of everything I'm going to use in my instruction are all located in processing units, so there's no addresses to compute. So this takes memory to do that, and so I'm not accessing memory with this instruction. So we don't do anything in this state with the add instruction. So then we go to the next part of the cycle, which is fetch operands. And so here,
What happens in evaluate address?
let me do that one in a minute, right? There's nothing for me to do in an add instruction, so I'm not calculating address. So it's going to fetch operands. So our operands are up here. So operands are R0, R1, and R2. So it goes and says, okay, R1, R2, and then this is going to go to R0. So then now it knows and loaded into the LU what the values that are needed to do the add instruction. So then last is to execute. So now it does the arithmetic in the LU, and after it does that, last part is to store result. So then whatever this addition was for this is now stored into the register. Right? And So then, after that executed, goes back up to the fetch state. And so PC is pointing to memory quotient 3001. So I'm going to actually do another instruction. Okay. This is my value. Sorry. So then it goes, grabs that, loads this into the instruction register. And then it increments the program counter. Right? So fetch is complete. We go decode. It goes decode. It sees that the upcode is a load. So now it knows it's doing a load instruction. Then it goes to evaluate the addresses. Right? Because I'm now going to access memory with my value. So basically, it has to calculate what is my value, right? It'll be more clear in a few weeks, but so it's going to take the current PC, which is at 3002, and basically my value is going to actually be a constant, a number. So we're going to say it's hex 10. So it's going to add 10 to this value here. So in hex 12, I'm sorry, 13. We're going to have a value in here. Say it's 1. So it had to calculate this the address on the value address, which my value was 10, added it to the PC, and then goes up. So that's all it did. So now it has an address of, and this happened inside here. So it has an address now of 312 is the address. So then it goes kind of weird. Fetches uprands. So we calculated the address of what we're going to work with, and all we need to do is say, oh, we're just going to store in R2. Basically, it's from whatever memory location here is going to be stored into R2. We're not using the ALU, so there's nothing to put into those in the ALU. So that's it.
What's the R2?
R2, basically what it's saying is, I want to store my value into R2.
What's that DR stand for again?
What's it?
What's that opcode?
It's a load.
Oh, that's a load.
Load, or I want to say it's load or a move, sorry. So basically I'm going to move from memory to R2. So I'm going to go from, let's see, we calculate the address from the calculated fixed address, and we're going to move the content, which is 3001, into register R2. So that's what's going to happen. So we know what we're going to store it into is R2. We're not using the ALU, so we don't actually calculate anything. So we don't have to evaluate anything. So then it goes down to store. So all now it does is take what was in that address that we calculated from this part of the cycle, and then we just store that into R2. So 01 is now loaded into.
Did you just make up that number, hex 1?
Yeah.
It didn't come from the hex 08?
No.
08.
No. I just made it up. Just to give an example of how it works. Like I said, when you start using the LC3, this will be a lot more clear. Like I said, it's one of those ones where I've got to kind of show you the flow of the computer, and they kind of give you some instructions. But I know they're kind of oblivious at the moment, but hopefully it gives some idea. Like I said, the key is remember the instruction cycle, and which one follows each other. You have to memorize this, memorize which one each one does. The book does go into good detail about this, and then I would memorize the picture of the Van Leeuwen architecture. One of your assignments.
You would memorize the?
I would memorize these and the definitions of this, and then I would also not to memorize this exactly, but I'd be quite familiar with it. And then, of course, remember your the LC3. Remember the instructions. Remember that the up code and operands are. Like I said, don't be too worried about these instructions. Like I said, there's going to be a whole chapter on them. Yeah.
Do you have a review for the test?
Yeah, there'll be a review.
Like a paper that says what's going to be on it and what we should study?
Like I said, Dan Gill put that on there for you. So, he should start chapter 5 Wednesday, so he'll start with chapter 5. Yeah.